What's good, math family? In today's video, we're going to look at 9 examples on how to add radical expressions. And I'm going to show you the 3 most common scenarios that you'll see with this topic. In the first scenario, we're going to be combining radicals where we don't have to simplify. And the most important thing with adding radicals is that the rules are different than multiplying. So for us to add, we just have to have the same exact square root. So the same number under the square root and the same index, which all of these follow that rule. Now that we know that, we just focus on combining coefficients. So now my first answer is just 7 radical 7. Second example, it follows that rule, same exact square root. Focus on coefficients. 5 minus 2 gives me 3. And our answer is 3 radical 7. Now let's say we go over to this example. Just remember, no coefficient in front of the radical. It's just basically 1. So when we add or subtract, just remember that. So 1 minus 5 gives me negative 4. Radical 3 as a final answer. And then in my last example, right, same exact square root. So we're good. We add, right, and this is going to be 15 radical 11. In scenario 2 now, the difference is they're going to give us at least one radical where we have to simplify before we could add or subtract. And typically this is when I teach my 3 rules. So rule number 1, is there anything we could simplify? We could simplify that. So first radical stays the same. So we simplify. I know I could turn this into 4 times 6. Now, after the first step, we simplify, right? The second thing that we want to do, and let's just finish simplifying this first. This turns into 2 radical 6. After we simplify in that first step, now we want to say to ourselves, hey, are there any common radicals, common square roots? Is there anything we could actually add? And if we can do that, we're going to try to simplify by adding or subtracting. So at this point, 3 minus 2 gives me 1. So our answer is just radical 6. I don't need to put the 1 in front. And even at this step, we'll check again. Third step is just to check, hey, is there anything else I could do? Answer is no. All right, so now we go over to this step right here, right? We notice, can't simplify that, stays the same, but we could do something a radical 12. So now I turn this to 4 times 3, and I take my simplifying one step further, right? Take the square root of 4, that turns into 2 radical 3. Step 2, I notice, hey, there are common radicals, right? There's something that we have that is common. And then step 3, now we're just going to simplify and see if there's anything else we could do after combining, and we can't. So 3 radical 3 is our answer. Now, last example, okay? 4 radical 7 stays the same. When I look at 28, we could turn this into 4 times 7. 4 is a perfect square. So once we take that out, we're going to multiply 2 times 2 to get 4, right? And now we notice that we just add 4 and 4, and our final answer is 8 radical 7. So this is scenario 2, and this is when, like I said, you're going to see one radical that you can't do anything to, and the other one where you have to simplify before we can actually add. And this is going to take us over to the last part of our video in scenario 3. Last scenario is when they give us radicals, and basically all the radicals have to be simplified before we can combine. So when I go here, we're going to turn 72 into 36 times 2, and 18 is going to turn into 9 times 2. Now, for those students who are asking about, I think it's 9 times 8 gives us 72, that will work, but then we're going to have to go back and simplify 9 because it's a perfect square. So always use the largest perfect square. It's less steps. All right, perfect square comes out. 6 radical 2 minus, perfect square comes out, turns to 3. 3 radical 2, we have the same exact square root, so we combine. Answer should be 3 radical 2. Now let's say if we go over to our next example, right? Same exact thing. So we look, no common radicals, we're going to simplify. 45 turns into 9 times 5 minus 8, and then we're going to turn 20 into 4 times 5. And we already kind of see the common square root slash radical, right? So this comes out, we're going to multiply the outside 3 and the square root of 9. So this gives us 9 radical 5 minus square root of 4 is 2. 2 times 8 is 16. We have 16 radical 5 on this end. And now, once we subtract, 9 minus 16 gives me negative 7. Remember, the radicals act as variables. We just bring it down. But before we go, I got one more example, and you guys have to see this problem because it's a common error or misconception that students don't understand. All right. So in this last example, I really wanted to show you all this because you're definitely going to see this problem. So when we break this down, right? We have 4 times 36 times 2. Simplify this to 6. 6 times 4 gives me 24 radical 2. Plus, and then we go to this next one. 11. We have 9 times, I want to say, is it 6 or 7? Let me make sure. Yeah, 9 times 7. I'm sorry, guys. I had to check the notes. All right. Simplify this to 3. 11 times 3 is going to give me 33 radical 7. And then at the end, we have minus 2 times radical 28. We did that already. That's 4 times 7. When we simplify, we're going to get 4 radical 7. So this is what I wanted to tell you guys. Yes, you've already seen and probably noticed that all of these square roots are not the same, right? Only these two are the same. And guys, that will happen. Do not think you did something wrong. That is the trick. Sometimes they give us problems where we can't combine. So 24 radical 2 stays the same. I focus right here. And I believe this should be 29 radical 7. So when we look at the final answer, this will be the final answer. And yes, we cannot combine those two radicals because they're not the same exact square root. Hopefully, this was a helpful video for you all on how to add radical expressions. Smash the like button, subscribe to our channel, and leave comments down below if you guys had any questions on this video or you want to see any topics in the future on our channel. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters.